Here we go. We got notes 5.2. We're going to graph linear inequalities and prove solutions. Remember, this is a video, so you can pause it, so you can write the stuff. So this is very similar to what we did in our last unit, but we're using inequalities. I'm sorry, not our last unit, our last video thing, right? And if you are in my class, we talked about inequalities right before the end of this beginning of this chapter, right, where we use the little mouths with half equal signs, or regular mouths. That's what we call them, just to help us with remembering. As long as you can do the math, right, that's really what's important. So we got line type, and that's where this is going to be different, right? It's still going to be in slope-intercept form, but we're going to have different type of lines. All right, so if you got a dash line, that's something that's not included, and that's where we use just the regular old mouths, okay? When we got a solid line, though, I hope this purple's not too dark. This is included, and this is where we use the mouths with the half equal sign. Now, the solid we have been doing, right? We did that in the last unit where we used these solid lines. Okay, and that makes sense because they had equal signs in them. So therefore, when you got a half equal sign, you still get to use a solid line. All right. Now this is where it gets a little bit different as well. So not only do we have to have a special type of line, right? We also got some shading going on, which we did before, right? When we had the number line and we like shaded across. So like here we go. For some reason I got a little number line right here. Remember how we did like an open dot and we would shade one way? We're going to do the same thing, except now it's with the graph, so we don't get to use the open dot no more. It's either going to be a solid line or a dash line. Okay, so with that being said, when we shade, we're focused on the y's, because slope-intercept form starts with y, blah, 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 okay? So when you got a smaller y, well, when you have it wrote out with an inequality, a smaller y is when the mouth faces away from it, okay? And on a x and y axis, right, if we're looking for smaller y's, when we look for smaller y's, we kind of look below at the bottom here, okay? So that means when we shade, if it's a smaller y, we're going to shade below. Versus if we got bigger y's, right, which is where the mouth is facing the y or eating the y, you know, from grade school. When you got bigger y's are always towards the top on a y-axis. So that means we would shade above, okay? So let me see if I got another couple of lighter colors going on here. All right, I got orange and yellow. All right, so if you see the y being smaller, you shade below. And if you see the y being bigger, you shade above, okay? So these are the two new things. So after we plot our points for the graph, we have to pay attention to these two things. Here we go. I'm gonna try and make this quick, but also slow at the same time. So this first problem, I'm gonna do too much, and I'm probably gonna do too much on the next problem, and then after that, you're gonna see a pattern kind of going on. So we got our equation here. The slope here is -3/2, right? Because that's attached to our x. And our b value is 1. I'm not going to go slow with this because we literally did this in the last section. This tells me to go down 3 and right 2. So I'm going to extend that. And then I go in the other direction because you always want to extend your line as far as you can. Now this is where I'm going to stop. And I'm going to pause, reflect, think, because I got special things going on here. All right, so first things first, I'm gonna look here to see what type of line we got. Well, see how this is a regular mouth? A regular mouth is not included, so that means we're gonna have a dash line. So for my line, it's gonna be dashed. So it kind of looks like your pen is stuttering instead of just drawing a straight line, like it's running out of ink, or there's like a jackhammer going on outside and you're going blah, 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 blah. So that's what a dash line is. The second thing we gotta do is we gotta shade. And what we do for this one is we look at the y value. All right, so my y, we have to determine if we got a bigger or smaller y. And in this case, we have a bigger y, right? So it's a big y. So that means we go above. All right, so from this line, we're gonna shade above. I am going to be crazy pants. I don't want to see your coloring go past my line. All right? So just, shade with caution. Show me where the shade's going on. It doesn't have to be super perfect, but it's got to be, pretty obvious where you're shading. Okay, but don't go past the line. All right, so we have the new graph. This is the new thing, the dashed and if it's above or below. Now we're going to prove some things because I like to do too much. All right, so we got to determine if A is on the line. So we got to determine if A on the line. So in this case, that is, where'd my pencil go? We got 2, -2. This is A right here, this point. We have to determine if it's a solution, just like we did yesterday. All right, so we use that original equation. And then we replace our values, right, which were given here. So I got -2, and the x is going to become a 2. All other numbers and symbols remain the same. -3/2 plus 1. All right, then you evaluate each piece. So -2 stays how it is. I use my calculator, Desmos, scientific calculator, whatever you want. Let's see, it's 2, 3, it's -2. All right, so some of us immediately would see this and go, oh, this is right. But think it through. -2 is greater than -2. No. This is false. Okay, this is false. So we're going to make a love note statement to ourselves. Right? Points on a dashed, or in more formal language, not included lines are false. Right? They will not be solutions. That's what I'm saying when I say false. Okay? And that makes sense, right? If you think about it, a dashed line means it's not included. So that means points that would be on that line would be not included. Isn't that crazy? All right, so the next one we got is 4-1. All right, it's in the shaded area. So if you want to take a guess before we go through. Do you think it's going to be true, or do you think it's going to end up being not true? Let's find out. So we got y, once again, using that same thing going on here. We're going to replace, I'm not going to use the, yes I am. We're going to replace our x and our y. We got y, we got 4, right? All other numbers and symbols remain how they are. The only thing we change were variables. All right, we do some evaluating. So we got what, 2, -6, this is -5. All right, let's think about this. Is 1 bigger? That's what this mouth is saying. Is 1 greater than -5? Yes, this is true. So that means for our love note, points in the shade are true, or they are solutions, right? If you say true, that means it's a solution. So that's a love note to ourselves. Points in the shade are true. Then we gotta point out of the shade. Take a guess. Do you think it's gonna be true, or do you think it's gonna not be true? Here we go. I'm gonna do this quick because number 1, I'm getting tired, and number 2, we've done this twice now. So I'm gonna replace this y, right? We got our x and we got our y. Replace this y with the 1, replace the x over here with the -3. But all other numbers and symbols have not gone anywhere, so don't make them go nowhere. Plus 1. We got 1 is greater than, oh goodness. We got, let's see, this is 9/2 plus 1 is 11/2. I hope that's right, all the math critics out there. All right, is 1 bigger than 11/2? All right, if you don't know, you could figure out what 11/2 is, right? If you're not sure, that's 5.5. Make it into a decimal because everybody seems to like decimals more. Is 1 bigger than 5.5? If I did this, that would be a no. All right. So we can make a love note saying points not in the shade are false. All right, so far, right, we got points on a dashed or a not included line are false, and we got points that are not in the shade are false, but we do have points that are in the shaded area. Those are true. Here we go. Ready? Remember, this is a video, so if you're like, you're going too fast, you can always pause it. All right, in this case, this is already set up for us. It's a slope of, because I know it's a slope because it's got an x and a y. It's got both. So I got a slope of 1 over 3. However, I don't have a y-intercept, and those of you who are going to freak out, there's nothing else there. Now, there's nothing, so that's going to be a 0, okay? It's not like this, right? Where people see this and they go, oh, my slope is 0. No, there's something there, right? You got something. You got this x, and there's technically a 1 in front of that x. So your slope would be 1. So be careful. I see that all the time. All right, y-intercept 0, 0. I can go up 1, right 3, all the way through. And I can go in the opposite direction as well. I'm not taking the time to go over slope again. What I am going to go through is what type of line we got. So I look at this. We got a half equal sign. So that means it's solid, right, from our notes earlier. So it's like the normal line you typically drew, and it's only because it's got that little half equal sign, which means it's included. And then we look at our shade. What are we going to shade? Let's see. We can look at our y. We got a small y this time. And if you have a small y's are always towards the bottom. So we're going to be going below when we shade. All right. So once again, shade below. Don't go past the line. You can get as close as you want, right? But don't go past it. And then do your shading. Okay? But don't go past that line. All right. Here we go. Now, it says for letter D, it's going to be on the line. So we got this letter D right here. All right. We're going to prove if it's true or not. So here we go. Using our equation, we're going to replace our y with a 1, and we're going to replace our x with a 3, right, from these. Using my math and my calculator, I get 1 for this side. So 1 is less than or equal to 1. That is true. Okay, that's true because we have that little half equal sign going on at the bottom. So we can make a statement that says points on a solid or included line are true. What? Okay. So, and that makes sense, right? Because the solid line is included. So the points on there would be included as solutions. Wow. I know, I'm amazing. All right, so this time we have, this is not ready for us to graph, right? It's got 5x minus y. This is in that standard form from yesterday. So what I'm going to have to do is get y by itself. So I'm going to subtract that 5x on both sides. And I'm not going to line them up because they are not like terms. I almost did. Did you see that? But I'm not going to line them up. These guys eliminate. We're left with negative y. My inequality doesn't change when I subtract things. And I'm going to bring that down. Now I still technically have a negative 1 in front of this y. So what I'm going to do is I'm going to divide negative 1. And if you do it on one side, you do it on the other side, which is super great. But this other side has more than one piece. So what's going to happen is I have to divide each of those pieces by negative 1, right? This only works with multiplication and division, okay? This don't work with anything else. It don't work with adding and subtracting, just multiplication and division. All right, now I divided by negative 1, so my inequality actually gets flipped, right? We talked about this in Unit 4. You're left with y is less than 2 divided by negative 1 is negative 2. And then we got negative 5 divided by negative 1 becomes a positive 5. Don't forget to bring down your x. All right, it's a little backwards, but my slope is 5 over 1. Put a 1 under it because it wasn't a fraction. right? This isn't a fraction here. And then my b value is -2. So start at -2, go up 5 over 1. I can't do any more. Go down 5 over 1. There you go. That's my graph. Okay, all the points I can plot. I look at my inequality here. It's dashed because it doesn't have the half equal sign, so I'm going to make a very terribly drawn dashed line here. They're never good. Oh, those yucks. And then we have my y. We got a small y. So that means we shade below. So remember, when you shade below, if you're kind of like, oh, where's the below? Start with the y-intercept. We want to shade below the y-intercept. So we got to shade this stuff. Remember, don't go past the line. Yoink. So all this stuff is technically below that line. There you go, just like that. Now, a point on the line is, so if we put a point, if we pick one of these points on the line, they would be not true because not included, right? A dashed line is not included, right? Not included dash line. Okay. Now, point E is 5, 2. 5, 2, 5, 2, 5, 2. Where's you? Right here. 5, 2. Right away, we know this is going to be a solution because it's in the shaded area. Okay, we know that with our brains because we proved something like that earlier. But what I want us to do is still prove it mathematically. So using my equation here, we got y is less than -2 plus 5x. Instead of a y, we use a 2. Instead of an x, we use a 5. Right? Do some simplifying. We get 23. This is true, and we prove that it is a solution. Even though we know visually it is, it's good to prove it also mathematically because you might not be able to plot that point on the graph. All right, number next. All right, another problem. This is not set up in slope-intercept form, so we got to go through and do the things with the math. So I want to subtract this x from both sides, and I'm not going to line it up with the 3 because they're not like terms, and I wanted to move that whole thing. So I got -y is less than or equal to 3 minus x. All right, so what I'm going to do here, I'm going to do two things. Both this x and this y have an invisible 1 in front of them, so I'm going to put them there because I don't want to forget about them or accidentally make a boo-boo. The next thing I'm going to do is I got a -1, so I got to divide it. And just like the last problem, we'll divide each of the pieces because when you multiply everything. When you divide everything, okay? When you add, you're specific to the like terms. And same with when you subtract. Now my inequality is going to get flipped because we are dividing by a negative all the way through. So my y is still there. This becomes a -3. This becomes a +1. Don't forget your x. Slope is 1. Y-intercept is -3. I'm going to change my slope into a fraction so it helps me graph. I got -3. The slope tells me go up 1, right 1. So I'm going to do that all the way through. And then I'm going to go in the other direction as well. Now, I'm not going to draw my line yet because I have to determine what type of line we got. So I have a half equal sign, so that means we are going to use a solid line. So it's kind of like what we normally have been doing when we saw equations with equal signs. Then I gotta look at my y. I got a big y, right, because the mouth is eating my y, so that means my y is bigger. So if we got bigger y's, we shade above because that's where we find bigger y's. All right, once again, you want to start at your y-intercept, and the bigger y's are above it. So I know I got to shade all this stuff above it. Don't go past your line though, or else it'd be considered wrong if you accidentally shade. And I'm gonna be a crazy psychopath, so make sure you do it right. Okay, now a point on the line. So a point on this line would be true, or a solution if you would, because the line is solid, or if you want to say also, you could also say included. All right, if you got an included line, you got an included solution on that line. All right, we're going to prove if this point F, 0, 0 is a point. First off, you can say yes because it's in the shade. But what happens if we didn't even have that graph to help us? That is where we would use our mathematical knowledge of plugging in variables. We got 0 for the y, we got 0 for the x. Using my handy dandy calculator or mental math, is 0 bigger, I'm sorry, let me say that right. Is 0 greater than or equal to -3? And the answer is yes. Zeros are always bigger than negatives. So we proved it mathematically that it's true. Last two. Okay, we have x is greater than or equal to 2. So once again, this is one of them weird ones, right? There's no y in this problem. So that means we do not have a slope. This is where we got to think about what we see, right? We did 2 problems like this in the last chapter, section. All right, we have x is greater than or equal to 2. First things first. Here's my x, here's my 2. I can only go through this 2. So right here, I can only go through this 2. We know it's going to go up and down. What we need to pay attention to is that it's a solid line. So I get to have a solid line going through this 2. Right? We did this in the last section. It was the last 2 problems. But we still have to shade. Right? Now again, I don't have a y, so I'm not going to be shading above or below. What I'm going to pay attention to is this x is a big X. So that means we have to find bigger sides. Well, I'm going to the bigger side of this 2 for the x values. The bigger side is going in this direction, right? Then I got 3, got the 4, got the 5. So that means this is a side we want to shade. Okay, so you just got to think about it. You have all the information, you just have to dig a little deeper, like they say in Princess Frog. Okay, this one, there's no x. Okay, so that means this is not a slope. All right, there's no x, so it can't be slope. So it's going to be the other one. This is going to be where we go across. Okay, so it's going across, it's going to go across at the 1 here. We know that. Okay, what we need to figure out is what type of line we got. And in this case, it's a regular mouth. So it's going to be a dashed line. So as I go across, I got a dashed line. Try to make it so that I can see that it's dashed, because I am old, I am blind, and if you're not going to be obvious, I'm going to assume it's wrong. Okay, so we got a dashed line. Now, once again, we got to figure out where we shade. Well, we got a small y, right, because it's smaller. Well, we already talked about where small y's are. Small y's are below, right? This one's kind of easy because it's using that y again. So that means we shade all the stuff below. All right, that's the end of the video. Always feel free to watch it again.